Hello everyone, welcome to my civil engineering YouTube channel. Please subscribe to it and hit the bell icon to get notified when I post my new videos. Today I'll be discussing regarding introduction on normal thrust and radial shear, and then I'll be solving a numerical on the normal thrust and radial shear. So basically what is a normal thrust? So normal thrust is nothing but I have just considered a sketch here. So the first sketch represents a three-hinged parabolic arch wherein which is subjected to the external load, and the second sketch represents the normal and the radial forces along the arch rib. So here it is a this third sketch represents the schematic representation of the forces which are acting. So here if I just consider the support A, so it is a hinged support. You will be having VA and HA as the two reactions here. So if I just draw the resultant, it will be along the inclined direction. Let me consider that inclined force which is acting at an angle of phi. Okay, so then normal force is nothing but a normal. If I just project that, this dotted line along the inclined axis represents the x and y axis of the arch rib. So HA here represents the horizontal force, the horizontal reaction, and VA represents the vertical reaction here. And here along this dotted line, it represents the normal thrust, and perpendicular to this line represents the radial shear. So as I said that phi is an angle wherein it is equal to that of the angle where the resultant is acting along the x-axis. So the total force, normal thrust is nothing but a total force which is acting along normal direction is through the arch rib. It is called as normal thrust. So normal thrust, it is a total force which is acting along the direction of the arch rib, and it is called as normal thrust. You can just see this sketch here. So here along the direction of the arch rib itself, there is a dotted line which is represented, which is nothing but the representation of the normal thrust. So coming on to the sketch here, so normal thrust can be resolved into two components along the x-axis, since it is having only two forces here, that is HA and VA. So the normal thrust components will be equal to HA cos phi, and then VA cos 90 minus phi. So here the total force, the total normal thrust will be equal to HA cos phi plus VA sin phi. Since it is VA and HA is acting along the positive direction, so it has taken both as positive itself. So therefore the general expression for the normal thrust is nothing but HA cos phi plus VA sin phi, where phi is the angle of the angle between the normal thrust to that of the x-axis. So again, the radial shear is nothing but the total force which is acting along the radial direction, or it is also called as the perpendicular direction. So radial shear is nothing but it is the total force which is acting along the radial or the perpendicular direction of the arch rib is called as the radial shear. So here I can just represent it as HA sine component of phi minus VA sine component of 90 minus phi. Why I have taken VA sine component of 90 minus phi here means So here VA is acting in the VA is acting in the upward direction. In order to counteract this VA, I have taken this I have taken this force in the opposite direction, which is of in the equal magnitude. So VA cos phi. So therefore the radial shear, the general expression for the radial shear is HA sin phi plus VA cos phi. So you can just take the application here as the normal shear. It has a normal thrust, it is represented as in this direction, and radial shear will be always perpendicular to the normal thrust. So coming on to a numerical to determine the normal thrust and radial shear for a three-hinged parabolic arch here, I have taken a three-hinged parabolic arch here. So whose span is 20 meters and raise is 5 meters. It carries a UDL of 20 kilonewton per meter at half of the span from the left side. Therefore, the UDL span is equal to 10 meters. So the total height of the rise is equal to 5 meters, and also it carries a load of 120 kilonewton at 5 meter from the right side of the support. Therefore another 5 meter it will be through from C to the load span itself, C to the load itself. Therefore and also they have asked to find out the normal thrust and radial shear at the section 4 meter from the left part. They have suggested to find out what is the radial shear and normal thrust at 4 meter from the left part. So if I just consider 4 meters as x, and therefore it will be having the rise as y. So D is the point wherein the load is acting. So it will be equal to YD. YD is the height between the support level to the point wherein you have to find out the normal thrust and radial shear. So the first and foremost thing is that you need to determine what is the support reactions. So there are two supports here which are hinged in nature. So you will be having two reactions. One is in the vertical direction and one is in the horizontal direction. So VA plus VB is equal to there are two external forces which is acting. One is in UDL nature and one more is in the point load in nature. Therefore it is acting in the downward direction. I have considered as upward going forces is equal to downward going forces. So VA plus VB is equal to 20 into the 20 into the span to which load is acting is 10 meters. So 20 into 10 plus 120 is the exact load which is acting. So it is in kilonewton itself. No need to multiply with the span. Therefore you need to take it as it is as 120 kilonewton. Therefore VA plus VB is equal to 320 kilonewtons. Now in order to find out the VA or VB, you are supposed to take the moment either at the support A or at B. So I am going to take the moment about support A into consideration. Therefore, if I take the moment about A, so I have to consider the moment from B to the reference point A. So VB into 20, since it is acting in the anti-clockwise direction, VB into 20, it is acting in the anti-clockwise direction. Here in this convention I have taken anti-clockwise as positive and clockwise as a negative. So VB into I have taken anti-clockwise as positive and clockwise as negative. VB into 20, it is in anti-clockwise direction, hence I have considered it as a positive. And then 120 into here the distance is 10 meters and here the distance is 5 meters. So 120 into 15, it is in clockwise direction, hence it is taken as negative. So the remaining force is 20 UDL. So 20, it is acting to a span of 10 meters. So 20 into 10 converted to kilonewton. Therefore another 5 meters you are supposed to multiply, since the moment at the centroidal point will be maximum. Therefore 20 into 10 into 5. So here I have to considered anti-clockwise moment as negative positive and clockwise moment as negative. So vice versa also you can going to consider, that is nothing but clockwise as positive and anti-clockwise as negative. You will get the same results. So solving the second equation, you will get VB as 140 kilonewton, and if you substitute that VB in equation 1, you will get VA as 180 kilonewton. Therefore, I have found out both the vertical reactions. I have left out to find out the value of the horizontal reaction. So in order to find out the value of the horizontal reaction, I need to take the moment about a crown point. So either from the left of the support or right of the support. So I have considered the moment from the left side of the support. So VA into 10, it is in clockwise direction. So it is positive. VA into 10 clockwise direction is positive. So here and again 20 into 20 into 10 is the 10 is a span which is acting, and 10 by 2 it is a centroidal point. So 20 into 10 into 5. So again one more force is H. So H into the rise distance is 5. So H into 5. Again it is in anti-clockwise direction. Therefore it equate that to 0. So always moment about the crown will be equal to 0 itself. Therefore if we equate that to 0, the unknown force can be determined. So H will be equal to, after solving and simplifying the equation, H will be equal to 160 kilonewton. Next, after finding the values of the support reaction, the second important step is that you need to determine the moment about the 4 meter span from the left side of the support. So they have given the point D, which is acting 4 meters from the left span. Let YD is the distance, the vertical distance from the support level to that of the point D. So here I need to consider what is a moment acting at point D. So I'm considering from the support A. So either you can consider from support B also, and then you need to minus that of the value what it has been asked. But here you need to consider from 4 meter from left support itself. Therefore I have taken A point as a reference point. So yeah, moment about D is equal to VA into 4 clockwise, hence it is positive, and then 20 kilonewton per meter it is acting. It is not for the span of 10 meters, but it is a span of 4 meters. Why it is 4 meters? Because I have considered the point D here, wherein the point D it is acting at the distance of 4 meters. Therefore 20 into 4 it is acting, it is converted into kilonewton. So the centroidal distance is 2 meters. Therefore 20 into 4 into 2. So it is acting in anti-clockwise direction. Hence it is considered as negative. The last force here, left out force here is H. The horizontal reaction H into the perpendicular direction for H is YD here. So H into YD. So it will be in the anti-clockwise direction. So H into YD. So after determining the after finding the general expression, we need to determine here is YD. Since all the forces are known here, YD is unknown. So we need to determine what is the value of YD. The given arch is parabolic in nature. Therefore we know that for the parabolic arch, the expression for y is equal to 4hx into L minus x divided by L square. That is the expression for the rise, height of the riser in case of the parabolic arch. Therefore here in case of H will be the total height of the rise from the support level to that of the crown. So it is equal to 4 meters which has been given. So and then 5 meters it has been given. So x is nothing but the distance to which the y has to be calculated. So here x distance given is 4 meters, since at the point D we are supposed to calculate what is the moment. So distance between A to D is 4 meters. Therefore x will be equal to 4 meters. Then L is the total span distance. So the total span here is from support to support span distance we are going to consider here. So L is equal to 20 minus 4 in divided by 20 square. So therefore YD will be equal to 3.2 meters. So you can just compare with that of the total riser. It will be always less. Therefore, substituting the value of YD in the equation 4, you will get the value of MD as 48 kilonewton meter. So, you will get the value of MD as 48 kilonewton meter. The next step is solving for the normal thrust and radial shear. You need to differentiate equation 5. The equation 5 here is y is equal to 4hx into L minus x divided by L square. So you need to differentiate the equation 5 with reference to x, so that you will get what is the value of theta. So why I need to differentiate with reference to x means, so as I know that the normal thrust and radial shear, in the beginning of this lecture series I have given a expression wherein it contains the value of phi or theta, that is the angle value. But here in this question, it has not been mentioned any of the value of theta or phi. So for determining the value of theta or phi, I am supposed to differentiate the value of y, so that I'll get the value of theta in terms of tan. Okay, so dy by dx is nothing but the slope of the arch, so that is equal to tan theta, that is equal to 4hx into L minus 2x divided by L square. If I just differentiate with that of x, I will get the expression like this. So after differentiating that, I need to put the values. So h will be equal to 5 here. L is equal to the overall span, that is 20 meters, and x is equal to 4 meters. So if I just substitute that, I'll get what is the value of tan theta, that is equal to 3 by 5. So if tan theta is equal to 3 by 5, so if tan theta is equal to 3 by 5, so sin theta will be equal to, so as I know that tan theta will be opposite by adjacent, right? So if that is equal to opposite by adjacent, so sin theta will be equal to opposite by hypotenuse. I need to find out what is sin theta and cos theta out of this tan theta. So 3 is the opposite side and 5 is the adjacent side. So if I just take the square of that summation, I'll get what is the hypotenuse value by using the Pythagoras theorem. So I'll get what is the value of sin theta as 3 by root of 34 and cos theta as 5 by root of 34. So by this the normal thrust will be equal to normal thrust at point D is denoted by Pn. Pn is the normal thrust force at point D. So is equal to HD cos theta plus Vd sin theta. HD cos theta plus Vd sin theta. So here HD refers to at from point A till the point D, what all the summation of forces in the horizontal direction, that is represented by HD. It is not only the force acting at A, it is a summation of forces acting at D in the horizontal direction from A to that of D. So VD refers to the summation of overall vertical forces which is acting from A to that of D. It is not only VA. Okay. So here VD is equal to VD. I need to calculate VD here. So VD is equal to, so from A to D, if I just consider VD value, so only two forces which are acting in the vertical direction. So one is VA and another is 20 kilonewton per meter, which is acting at the 4 meter span distance. So VA is acting in the upward direction, hence it is taken as positive. So minus 20 into 4. Therefore, this summation totaled will give the value of VD. So VA is 180 minus 80, it will be equal to 100 kilonewton. Now coming on to HD value, HD is only the horizontal, HD is the total summation of the horizontal forces from A to D. So if I just see this sketch here, so I can only find out only one horizontal reaction is observed here. So that is nothing but the H value. So you can just take H as equal to HD itself. Therefore, HD is equal to 160 kilonewton. Therefore, the normal thrust will be equal to HD cos theta plus VD sin theta. After substituting this value, I'll get the normal thrust as 188.65 kilonewton. 188.65 kilonewton. Now, after finding the value of radial shear, normal thrust, radial shear shall be found out by using SD is equal to HD sin theta minus VD cos theta. HD sin theta minus VD cos theta. So after finding this, HD you need to substitute as 160 and VD as 100. So sin theta and cos theta values are identified. So just substitute and get the value of the radial shear. Okay. So after finding that, you will get what is the value of horizontal thrust and radial shear. Thank you.